It did beep. Excellent. All right. So yeah. So thank you again for coming and welcome. We're going to talk about monkeys. We're going to talk about something that is called the Chasm and the craft and something that we call the chain. And we're going to talk about all this stuff in context of solving a very, very big problem, and that's a trust problem with AI. You obviously know all that. You know that we have this problem. It's not only you. We now have a lot of research done in the last couple of years that talk about the code quality of AI-generated code. Wait a second, important stuff. All right, I'm ready. Okay, good. Sorry about that. That was like, right. So the quality is not great. This is a research a couple of years ago, and it speaks about how it generates correct code 65%, 46%, and 31% of the time, different models. Basically, like around half of the time on average, the code is correct, which is not great. Newer research, this is from this August, couple of months ago. So basically what the folks from Sonar found is that, you know how every 2 weeks there is a new model that is the best model out there that beats every other model on something that is called the PAS1 benchmark. There is a benchmark that generally measures how good coding models are, and every new model is the best model on this benchmark. What they found is that there is no correlation between how well the model does in this benchmark and the actual code quality. Which is kind of sad, but also, I guess, not surprising for whoever ever tried that. It brings a very natural behavior. This is from research done, not research, that's a survey done by Kodo that measures two things. How well the model does, the hallucination frequency, and do we trust it? Again, completely unsurprisingly, wait a second. Oh, it doesn't know how to do that on the screen sharing. Okay, more than 75% of us see that the model hallucinates and doesn't trust it, which again, not surprising. Let's do it right here. How many of you think that the code that is generated right now hallucinates and is not to be trusted? Here we go, 76.1%. Perfect. Right, okay, Stack Overflow survey. Now, Stack Overflow is a little biased anti-AI for the obvious reasons. The 5 people that are still on Stack Overflow patiently hate AI. You can see here, and those 5 people cannot leave because they have such a huge rating. It's a sunk cost. But you can see here that more than 50% are between somewhat distrust and highly distrust AI, again, for the obvious reasons. This is an interesting metric. This metric is called code churn. Churn is basically when people, companies, whatever, leave, and they use the term code churn for code that is thrown away shortly after it's written. If I remember correctly, they measure 3 months. So the code that didn't survive longer than 3 months and was thrown away. And you can see here a very sharp incline of code that is now thrown away shortly after it is written. And they assume that that's because this code is generated by AI and hence not good. Now, it's not necessarily a bad thing. Right, disposable code might be good for some scenarios, but the sharp incline basically suggests that the code that is produced now is less permanent than the code that was written before. Security is another huge concern with AI-generated code. Again, kind of old research, but I think still very relevant. 40% of the code generated by AI has security vulnerabilities. 40%. It's pretty scary. And back to the Sonar research, they found that generated code have stuff like hard-coded passwords, path traversal vulnerabilities, and basically a bunch of other security vulnerabilities. That's also kind of a big deal. API, I don't know how to pronounce it, API Arlo, I guess, maybe. They also did a research that actually shows a very sharp incline in payment data, which is basically credit card numbers, hard-coded in code, and missing input validation and any kind of authorization on APIs. So basically APIs that can be accessed without any authorization at all. Again, you can see very, very sharp incline, and that's, again, attributed to the amount of generated code. Well, if you ask AI to fix problems generated by AI, you get exactly what you expect. Right, so it fails to generate correct code and then self-verify its correctness. It fails repair buggy code and then self-verify whatever bugs were resolved. And it explains incorrectly the code that it generates. So obviously it cannot fix it because it doesn't understand what it actually generates. Fun times. Fun times. That was a very gloom introduction. My name is Baruch Sadogurski. I'm at jbaruch on all the socials and wherever. Head of developer relations in a company called TaxCare. So we do absolutely awesome t-shirts. Except of doing awesome t-shirts, we also provide security patches for end-of-life software. So if you work in an organization that cannot get the latest version of whatever open source dependency you work with, and now maybe you don't really want to, especially after this opening, talk to us. We will make sure that you can upgrade on your terms and not whatever library or maintainer declared that it's end of life for them and no more security updates. Java champion, wrote a couple of books, DevOps tools for Java developers and the liquid software. The most important slide of this talk is this. If you go to shownotes.taxcare.com, the slides are already uploaded. The video is successfully being recorded. So depending on the Wi-Fi quality on the hotel, it will be up either by tomorrow morning or maybe a couple of days after. All the links for everything that I'm mentioning, including all the research that we spoke about and everything that is coming up is already there. And it's conveniently on the bottom of every slide. Together with hashtags for intent integrity chain. You will see now why very soon, and the Utrecht JUG handle. So when you go online and praise this talk, mention Utrecht JUG for hosting us, and intent integrity chain hashtag. You can scan the QR code. While you do it, I'm going to share with you that there is a very nice price for you to just being here. If you go there, you will see it. It's like a retro keyboard, mechanical keyboard, very sweet. Go there and sign up for the price as well. And I already mentioned awesome t-shirts. I do have a bunch of t-shirts to give you for interesting conversation, questions, and what's not. So feel free to ask those and you will be rewarded. Okay, now you don't have to scan the QR code because the URL is very simple and it's in the bottom of every slide. Okay. I promised you that we are going to solve, I didn't, but now I do, that we are going to solve the problem of trust that we have. And to understand where it comes from, we need to go back to the beginning of software and to question how software starts. Software starts with software definition document. This is usually a huge piece of text that is written once, never corrected or adjusted, and read maybe once. Because it's a lot of text, it's not super useful, it's usually outdated, and it's generally not very useful for developers that actually should write this code. Yeah, that's like the reason why it is exactly that way. Now, one of the problems is that we think we speak the same language, which is not necessarily true. And I will give you an example. I was in New Zealand yesterday, day before yesterday, this week. And I encountered a very interesting conversation. We were invited to some gathering, to a party, and someone showed up with an empty plate. Like literally came in and gave the organizer like a stack of plates, like paper plates. And the organizer was extremely surprised. He was like, he didn't say anything because it was not polite, but you could see that he was in incomplete shock. Like, what do you mean? Did you imply that I don't have plates? Why did you come with empty plates? Anyone knows what happened? So in Australia and in New Zealand, they have a saying, bring a plate, which means bring your own like dish to contribute to the gathering. And it was absolutely not clear that the expectation was that it will be something on a plate. And this person actually thought that they should bring plates because maybe the organizers don't have plates. What I'm trying to say is, even when we speak the same language, like English, for example, we don't really speak the same language. There are a lot of reasons for that. One of them is known as curse of knowledge. Curse of knowledge is a cognitive problem that whatever we learned and understood seems trivial to us. Think about it. Even some concept that was kind of hard to grasp in the beginning, once you understood it, now you think about it like, well, obviously, duh, because you understand it and it's completely clear to you. And that makes it very hard for us to explain, because we expect that something so trivial is understood naturally by other people. I don't know how many of you had this experience, maybe in school, maybe in university. I remember coming to a class, and then like in first 3 minutes, the professor goes like, hey, welcome, introduces themselves, and you kind of start to doze off because that's boring. And then you come to your senses like a minute later, and the blackboard looks like that. And you're like, what did I miss? And that's because this professor started to explain something that looks trivial to them, expecting that it's trivial to you in an absolutely high pace and maybe not very clear, and you miss the entire thing because this professor had the curse of knowledge. And it's a cognitive bias that people who explain and teach know how to recognize, but not everybody, and especially not people who are professionally teaching. And think about the product managers and the business people who write those software definition documents. They have a very clear picture of what do they want from the software. It might be a wrong picture, but it's clear to them. How much of that will be clearly explained in those software definition documents is absolutely unknown. Is it like 70%? Is it 30%? You don't know. You as a reader don't know what the other people knew when they wrote this document. So why software definition documents don't work? Because human misunderstanding. It can be curse of knowledge, it can be cultural differences, it can be context, which is not always shared, like, for example, the example with the plate. That is, it's a context thing, right? And vague responsibility boundaries. Who is in charge of making sure that everybody understood software definition document? Product people, business people, like, we told you everything there is to know. Developers like, this is what it was in the document. So yes, it's not what you wanted, it's your fault. No, we actually explained that you didn't implement it correctly, it's your fault. So who is in charge of making sure that this gap is breached, almost, is absolutely unknown. I don't know if you lived through this era in our industry. It was a long time ago, and it was absolutely stupid. It was absolutely stupid because it shouldn't happen. Because QA testers and like QC people are exactly on the same side with developers, and developers who take pride in their code actually want their code to be high quality, so they should be, and most of the time they are best friends with people who try to improve the quality of their code. So this is not a thing anymore. How many of you lived through this era in our in our industry? The preverbal silos and throwing software over the fence, and leaving the ops people to deploy your crap until 5 a.m. And this kind of stuff. This is kind of also solved with DevOps. Solved not in a matter that everybody do it, but at least solved in a matter like we know what to do. Whether you do it or not, it's a different question, but at least we know how this should be solved. But this is very real. This actually happens a lot and will probably happen till the end of days because as I mentioned, there are a lot of reasons why misunderstandings happen, why blame is constantly assigned, and why this is generally a friction between those two. So, you know what? We actually have this trust problem not only with AI. It's on a different level. It's not necessarily that we don't trust the code. You know what? Yes, product and business people don't trust the code that human developers write in exactly the same way, because it doesn't do what they expect it to do. Because they had something in their mind how their software should look like, and eventually the software looks different. So this problem exists not only with AI. And the next thing you know, you get this. That's a Venn diagram, by the way. But hey, sometimes we do have working software, right? Why? There are some reasons that help us overcome this distrust. The first and the most important one is good intentions, right? We're all in it together, and we all are in charge of writing good software. It includes the business people, the product people, and us technical people as developers, and we try to do the right thing. And this helps. And yes, we sometimes fight, we sometimes assign blame, but sometimes we also go beyond and reach out, and using good intentions actually fix the mistrust and misunderstanding problems. We take pride of the work that we do, and this also works for business people, product people, and technical people, and we all are in charge of what we try to achieve. And at the end of the day, if the software is not good, we take responsibility and try to do the right thing. We have tests, we have QA, that obviously also helps to do the right thing and deliver working software. And we have end result observation. We can look at the software and say, hey, that's not good, or hey, this is fine, or hey, this is something that needs to be fixed. And eventually we do have common-ish context, right? So most of the time we do understand each other, and we understand what, again, 70%, 80% of what other people mean, although we miss some stuff. It's not completely different context. Now with Gen AI, all this is out of the window, right? There is no such thing as intentions with AI that generates code. There is no such thing as taking pride of the code that it produces. It couldn't care less. Tests, as you saw, when it tries to fix the problems it creates, it does very poor job, because it's the same code generator that didn't generate good code to begin with. And there is no end result observation. It assumes that it wrote code that actually works, but it doesn't even care if it compiles not speaking about building, deploying, and looking at the end product. And obviously, there is no such thing as common context between us and neural networks, because there isn't. And this what creates what I call intent to prompt chasm. When a user asks the neural network, how do I use Spring Boot? This glaring lack of context brings a result like you cannot boot a season of a year, because there is no such thing as common context. So what we wanted to do and what it actually does has a huge chasm. It gets worse. LLMs are by nature stochastic systems, which means non-deterministic systems, which means for the same prompt, it will necessarily give us different results. And the problem with it, that it's not a bug, it's a feature. This is the only way how those networks can actually work. So the way they work in the broadest, like in the simplest description possible, is they give you similar things to what you asked. For example, if you asked for what is like king, it will return queen. Because queen is similar enough to king, but different. We can gauge how different we want the results to be, and this is called like the temperature. And we can say, I want things that are very, very similar, or I want things that are less similar. If we ask for things that are less similar by setting up our network temperature, we can get results, well, also a princess is like king. But it's less like king than a queen, because it's a different generation of royalty. Or we can set the temperature to give us very close things. So queen will be the only correct answer. But we can never lock it to be deterministic and non-variant, because then the only thing like king is king, which is absolutely useless answer. So this stochastic nature is not a bug, it's a feature. It cannot operate in any other way. And that means that by definition, for the same prompt, we will get different results. Which brings us to the infinite monkeys theorem. The infinite monkey theorem goes like this. If you give to infinite number of monkeys, infinite number of typewriters, and infinite time, eventually they will produce Shakespeare. Which, when you think about it, is definitely gonna happen. And also not very great way to produce Shakespeare. What we have with LLMs is exactly that. We gave them GPUs instead of typewriters, and the probability of producing the end result that we want is obviously higher than just random. But it's still not 100%. We still have this variability, and sometimes we will get something that looks more like Shakespeare or less like Shakespeare, and for our context, more like correct code or less than correct code, but we cannot guarantee that it will produce correct code every time, as we cannot guarantee that we will get Shakespeare out of those monkeys every time. Great way to write code. What can possibly go wrong? We have code reviews. That should fix it, right? Because now we have humans in the loop. We look at this Shakespeare and we can say, well, this is Shakespeare, but this is not. And we only leave Shakespeare in our code and we root out everything that is not. That sounds like a great idea. Not gonna work. Because looks good to me syndrome. Looks good to me syndrome is looks good to me as in every code review for every change. The problem, the reason for looks good to me syndrome is because we are busy with other stuff and couldn't be bothered to do code review. And even more importantly, we actually hate reading other people's code, which includes our code, which is 6 months old or older. But we do it anyway sometimes, and this is code reviews kind of work, because of professional courtesy for other people. What we definitely don't like to read is generated code. Because generated code has no intrinsic value of creation. No one that you respect put an effort into creating this code. It doesn't have value for other people. That's why it definitely doesn't have value for you. If I ask you to review my code, you'll grunt, you'll say, oh, I'm busy, I don't have the time. But eventually you will do it because you respect the effort that I put into this code. This does not exist for AI-generated code. AI-generated code worth nothing. And it is worth nothing, you have much less incentive to actually make an effort to read this code. Next thing we know, pull a request that looks good to me. Without, you looked at it, it looks okay, and then you pass it. Now the problem with this is that obviously this most of the time will be Shakespeare-ish, but not Shakespeare. This code might be even working, but it might not be good code, and no one actually checked it. So code reviews are not really working. This is what we get. How do we change it? How can we build this trust in AI-generated code to the level that we don't need to rely on code reviews that obviously don't work? How about we create something that will be verifiable? It means, what if we code our intent and then we can verify against this code? And this is what I call intent integrity chain. Now, is there a way to ensure that code does what we expect it to do? Is there? Tests. Thank you very much. That's kind of what you start with. Tests is a great idea to provide guardrails for monkeys and make sure that until the tests pass, the monkeys will keep typing and eventually will generate exactly what we want them to generate because the tests pass. Brilliant, right? We write the test first, we let LLM implement the code until the tests pass. And when the tests pass, we know that we managed to capture the intent in code. Easy, sounds great on paper, looks a lot like test-driven development, right? Perfect. There is a problem. Who writes the tests? Well, AI is definitely a bad idea to write the tests, but even when we decide that humans should write the tests, because humans know the intent, who writes the tests? Developers. But who have the intent? Product owners, product managers, business people. They are not going to write any tests. Not going to happen. So, yes, the problem of going from tests to verifiable code can be solved. But it doesn't close the chasm, because the chasm is here. Software definition documents written by business people and product managers and product owners, and then something, developers write tests and LLM implements it. We still have this chasm between those two. Next idea that we can think about, and obviously developers have not a great relationship with TDD anyway. Who implements TDD here in the room? Obviously, you'd better, but other than like 3 people. Yeah, okay, that's, yeah, pretty much. We can discuss why, and that's a fascinating discussion because, okay, who thinks that TDD is a great idea? On paper. But almost everybody. And then like 3 people actually do it. I'm in exactly that. I think it's a great idea, I don't do it. Why we don't do it? Because, again, cognitive biases. Developers are biased for action, which means that when we hear a problem, what goes through our minds? Okay, this is what we need to do. This is how we implement it. This is the happy path. This is how we get from the problem to the solution. We start thinking about how we solve the problem. And we want to go ahead and write it. And this is what we usually will do. What we don't do is thinking about, okay, how we're going to test it, and what are the exceptions, and what are the rare occurrences that we need to put in test. We might think about it, definitely, and we should think about it, and most of us do, but after we already implemented Happy Path and get the endorphins from working solution that we wanted to implement. This is exactly the problem, or not a problem, this is just human nature, but this is why TDD is so hard. So Hubert can tell us a lot of stories about TDD in general and how to overcome this bias. But this bias exists. And without very strong discipline, what we're going to do is we're going to write the solution first, which is valid. So yes, our product managers and our business people are not going to write tests. But what if it almost won't look like code? What if we write specs? And it looks almost like human language, might be English, might be Dutch, might be any other language. And then actually product or business people can read and theoretically write it. Is this gonna, so first of all, what this looks like? Yeah, BDD, right? Yeah, and then it actually replaces our software definition documents. It's a living documentation, it's a dream, and it looks like BDD, right? Looks very familiar again. How many of you implement BDD? Oh, actually, about the same amount of people that implement TDD, which is a nice surprise because it's usually half. And the problem with BDD is exactly the same. The business and the product people are not writing specs. Now here we have actually anecdotes of people who try to convince their product owners and product managers to write specs, and that's a very fresh anecdote from someone who came to me after this talk in a previous conference and shared with me that they came to product managers and they told them, hey, can you please do us a favor and write your requirements in this format? It will help us a lot because it's machine parsable, so we can automate it. And what they said is, this is very insulting because you take pride in your code and we take pride in our software definition documents. The way we do it is the right way to do it. This is our professional outcomes, and we are not going to diminish those wonderful documents into this, like, whatever you want to do, when, if, then sentences, because it misses the point of us creating the documents. Very artistic nature, we try to confine them into those boxes they hated. So definitely not going to do it. We're back to having the Chasm. Software definition documents exist, something, something, and then developers end up writing specs because no one else will, and then we generate tests from those specs, either implicitly or we run the specs, which is exactly the same thing, and then LLM generates code to the spec. We still have the Chasm because software definition documents, the context that they capture and the knowledge that is there is not translated to specs, and specs are not even written because if the developers didn't even want to write tests, which is code, they're definitely not going to write specs, which is not code. So yeah, we still have the problem, but here maybe LLMs can help. How about we let LLMs do the work for us? Software definition documents can be prompt that we can feed to the network and then ask it to generate specs. And then this is something we can ask the product and the business people to do. Reading specs is not something that's going to hurt their feelings because they're still participating in writing the prompts. And they can read the specs because they're almost natural language and check that what was captured in those specs are actually exactly what they meant in their beautiful software definition documents. And if they approve and they say, yes, you know what, it captured my intent correctly, then LLM can generate tests from the specs, and then LLM can implement the tests until they pass. This now actually completes the chain and captures the intent in a verifiable way, which looks nice, and it looks like the problem solved. Well, yes, but no. And the problem with this beautiful picture is stupid monkeys. The most important rule of AI assistant engineering is never trust a monkey. If you cannot verify whatever LLM did, you will necessarily get wrong results because non-deterministic, blah, 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 stochastic, blah, blah, blah. Let's see in our chain what can be trusted and what cannot. So artifact, the prompt, is created by humans, and that means that it cannot be trusted because, remember, context, we all speak our own language, curse of knowledge, and all this kind of stuff. Spec is generated by monkeys, definitely cannot be trusted. If we want to look at the spec, it might very well be that whatever we had in our prompt and whatever LLM hallucinated in spec are completely different things. Tests generated by monkeys definitely cannot be trusted. How can we make sure that the tests that are generated from the spec are actually matching the spec? And remember, tests are not going to be reviewed by business and product people because it's code, so it's kind of, we're not going to read code because no. And then the code that is generated by monkeys to pass the test also cannot be trusted because you remember the study that says that the monkeys will adjust the tests to the wrong code? This is definitely going to happen. The monkeys are going to change the tests to match the code and not do the right thing. So that's not very good. Let's see how can we fix it. First of all, we don't need monkeys in all the steps. We can actually do fine with algorithms which are deterministic for some steps. What we can do, for example, we can replace the monkeys in the test generation step because we know how to generate tests from spec. What Cucumber does is exactly that. Under the hood, when we say we run the spec as we run tests, Cucumber parses the specs, generate tests, run the tests, no LLM needed, 15 years old technology, no one knew about any LLMs back then, and it worked just fine. So this is exactly what we might use, and it actually hits all the spots. We have executable specifications, which are automated tests, which are living documentation. So once we replace the test generation from monkeys to algorithm, we can trust it. Now we know exactly that the tests that are running in our build are exactly what is written in spec. Now we can also solve the problem of monkeys changing tests to match the code. How can we prevent monkeys from messing with validation? That's exactly the next problem. We can lock the tests. And we are talking about the simplest solution possible. We can make the test classes read-only in the operating system. Once we do that, they cannot be changed. And this is actually a very simple solution to how we can prevent it. And for everything else, I'm going to quote Ronald Reagan. The year is 1988, a summit in Reykjavik about nuclear disarmament, and President Reagan tells Gorbachev, "Доверяй, но проверяй," which obviously a Russian proverb that says, "Trust but verify." Trust but verify means, yes, we totally believe you that you are going to disarm all your nuclear warheads, but let us send some people to actually watch over it. And this is exactly what we have in monkeys. Probably the same level of trust as between USSR and America back then. This is what we have now with AI, so we need to verify. What can we verify? First of all, we can verify prompt. And this is our software definition document that should be read by everybody and generate consensus. Yes, this is exactly what we want out of our software. But more interesting is that we can verify the spec. Yes, it is generated by monkeys from the prompt, and it might not always be accurate, but since spec is human readable, we can get everybody to read it and approve it. And there is no excuse for business people, product people, not to do it. This is part of their job. Once we get approval from them that the specs are exactly match what they had in mind and what they wrote in the prompt, this is where we have the verifiable chain kicking in, because the tests are generated by algorithm, so it's completely safe, and then code is protected and it's completely safe, right? So the business people won't read that, but we don't need it because this is actually verified by the algorithm and we are good. So now this is actually something that we can trust, because software definition documents are our prompt, and then LLM creates the specs, but everybody read the specs and approve them, and from there algorithm generate tests and LLMs implement the read-only tests until they pass. Now here there is no room for anything that can go wrong as long as everybody do their job properly. So why does it work? Because everybody writes text, the prompts, and specs are verified by all, reviewed and verified by all because it's still text, and then software definition documents and specs are living documents, because if the specs don't match the prompt, what we need to do is go back and fix the prompt. So the prompt, our software definition documents, are always correct, because they have to be, because otherwise the code won't match what is written there. And everything else is derived from specs that were approved by text. And all the code is verified by machines, by algorithm, and by a test runner, which is also basically an algorithm. So thanks to LLM, we finally have BDD that can actually work, because we define and agree on intent, and then we verify everything that AI does, and we don't trust AI for what we didn't verify and we didn't read. And the example that I use here for that, and that's kind of the go-to tool when you think about BDD, is Gherkin and Cucumber. And the question is it good enough? We know that Gherkin specs are good for defining behavior because we've been doing it for 15 years and it actually works. But we usually do it for functional requirements. Non-behavioral constraints and non-functional requirements are hard to describe in the given when-then format. It is possible, but it's not natural. The good news are that this idea that I present you is not something that other people didn't think about. There is nothing here that is completely like, ooh, like none of the industry thought about it. The spec-driven development in AI is now all the rage. This is the hottest thing out there. In the last couple of months, we saw releases of spec kit from GitHub, which does not exactly, but goes into the same direction of the intent integrity chain. We saw a release of Kiro, which is an IDE from Amazon that, again, goes into the same direction of intent integrity chain. Unfortunately, it doesn't go all the way, but we can actually make it do the right thing. And if you'll go to the show notes, you will see there that we have another talk that actually implements intent integrity chain with Kiro, like a live demo that you can see how it works. And there is a startup that is called Tessel that does exactly that. You make the spec, AI codes and maintains, and the idea is that it's all verifiable. Tessel pivoted a little bit to something that they call platform specs now, and this is another very, very interesting discussion. So what Tessel does now, they provide specs for libraries that your AI uses. So basically, how AI knows how to use Spring Boot correctly. It can use the pre-trained data, which is not a great idea because pre-trained data will be like 9 months out of date. It can do general web search, which is not a great idea because there is a lot of not very correct information out there. Or it can use spec that is derived from official documentation and official code samples. And this is another type of spec. This is what Tessel calls platform spec. And they came up with the concept of spec registry. So basically what you do is you connect your coding agent or your coding IDE to the spec registry, and it will only use verifiable information from this source to actually make sure that the code that it generates is correct. It's a little bit different aspect of the term spec that they use, but it's also very, very interesting approach which complements intent integrity chain because eventually the code should use the right libraries in the correct way. So it's not instead, but it's a complement to what we spoke about. Yeah, Andrei Karpathy, the hottest new programming language is English. Very, very true. Has its own quirk as any programming language, but there is a way to actually overcome them, and this is what we spoke about. So intent integrity chain, to summarize, it generates consensus, features are verifiable back to the requirements, that's the whole idea of the thing, and we can start trusting AI code and solve the problem of trust that we started this presentation with. There is still work to be done, especially in this part of how do we make sure that the specs that are generated are still human readable, but also machine parsable, so we can go ahead and generate tests without humans or LLMs based on algorithms, but we are getting there. And this is something that already works today, although maybe not perfect. So with that, thank you very much. Edge Baruch, talk to me about TaxCare and end-of-life libraries, security patching and support. At Utrecht JUG, again, mention them and give them thanks for hosting us. And intent integrity chain is the hashtag. You go to shownotes.taxcare.com. The QR code is right there again. Going to stay there for a while while we take questions. And I remind you, t-shirts, yes.
We want to have this application for 5 million people. Do Are the non-functionals in the architecture this also because it looks like specs?
Yeah. Which one? What looks like specs? Sorry, I didn't.
So you talk about specs and
Yes.
business people,
Yes.
and what about scaling and
Scaling and stuff. Yeah. So this is what I mentioned, right? Yeah. So I mentioned that. How do you put in specs non-functional requirements? Scaling. I guess scaling is one of the best examples, right? Or maybe reliability, right? Maybe uptime. You have it in your requirements like in text. So the product people like, hey, we want 5 nines of reliability. Good luck now implementing it in when, given when then spec. This is exactly where we might need a better solution for specs than Gherkin and Cucumber. But you know what? Maybe some of it is solvable. So for example, scaling is definitely solvable because we can write unit tests that will do scalability testing. Well, it's not unit really, it's system tests. And we can write the spec that describes it. Not perfect, does more than you might think, but still not 100%. Maybe again, maybe we'll come with some better way to specking that will cover those requirements as well.
what security? How do you ensure that code is secure?
So security is easier, right? Because for security, you definitely come up with scenarios that check security. Right, so you can have scenarios that validate that your API's access are only authorized.
How do you ensure that code not something like
For like security vulnerabilities in the code, stuff like hard-coded passwords and credit card numbers, there are tools for that also do automatic testing. So Sonar that we started, the reason why they did this pure research is obviously to say, hey, you really should use Sonar to verify your code, which is a nice marketing plot, but it is actually a good thing to do, right? So there are a lot of tools that you need to employ to verify the code that is generated by AI, and there are security scanners that scan the code for those types of things. And this is not instead. So yes, we will have some spec testing that will check behavior, but we definitely need to do other type of testing as well, including load testing, including security testing, and all this kind of stuff. And this testing is also can be specified by spec, but also doesn't have to be. To plug in a security scanner, you don't need it to be defined in specs. You just need to plug in security scanner into your pipeline. Yes?
I do have a question. How can you ensure code quality up to the point where you have let's say, a large application with, let's say, a ton of spec tests, and everything works with each other, and you're scaling, and you're not really focusing on the code quality because, tests pass?
Beautiful question. How do you ensure code quality once the tests pass? Right? How do you know it's not garbage? Well, it is probably garbage. But you don't care. You don't care because it does what it's supposed to do. Now, we might want to make a mental switch from a code which is an asset to a code which is just a step in our compilation chain between human intent and machine code. Right? You don't care now if the what is called the bytecode or the assembly that JIT generates is particularly beautiful. You know what? It's the opposite. Most of the optimizations that just-in-time compiler will do for us will take our beautiful Java code and will create a very, very ugly assembly code. Not ugly because it's assembly, but ugly because it will, for example, unroll all the loops for us in some particular use cases and will repeat the same code like 20 times because it unrolled the loop, because it performs better. Now, this is obviously a terrible code that you will never want to be in your code base. The beautiful part is it's not a part of your code base. It's just some disposable middle language that goes between your beautiful Java code and CPU instructions. Now, what we have here is a step that is similar to that. Suddenly, our code is not something that we care about. Once we have our intent clear and understandable and verifiable, and the specs are correct, and they cover all the use cases, the generated code becomes disposable. It becomes another interim artifact. Now, there is a value in good code or clean code or whatever you call it beyond just like we take pride of it. And that will probably be about maintenance and about supportability of this code. But what we need to remember here is that we actually don't need to maintain this code. This code is disposable. Once the requirements change, or once we discover that there's something wrong, we fix it in the prompt and we generate new piece of code. And then it really doesn't matter if it's beautiful or not, as long as the tests pass. There is an interesting side effect of that, that in order for this system to be maintainable, it has to be very, very granular. AI-assisted code is the most important advocate for microservices you can think of. The smaller the chunks are, the easier they will be swapping in, swapping out, throwing away, writing a new one, and replacing. And it also will be the most verifiable in terms of us humans grasping the requirements and then the spec and understanding if it does the right thing. The smaller the spec is, the easier it is for us to understand it. And this is why the microservices now make a huge comeback with AI, because we want those micro pieces that we can scope and spec. We don't care about the code. We can throw it away, and then we can change it and generate a new small Lego piece that will fit wherever it's needed. Make sense? It's very hurting for us as developers, as people who take pride of their code, to think about code as disposable, but it looks like this is where it's going. Yes?
Interesting talk. And it was a very interesting path, like from prompt to the working system. Let's assume that it's a working system.
Let's.
The question is, could it be a problem, another chasm, like incompleteness chasm, on a level when the spec is generated? For now, we have two groups of people, like business people and technical people. Yes, sometimes we don't understand each other. We try to communicate, but at the same time we try to complement each other. So if something is missing from business requirements, we can come, we can discuss this question and could be fixed if it's not clear for us. If in this path, let's say, if everything is generated, when could we be sure that the completeness is achieved?
Yeah. So that's a great question. In the end of the day, when we write code, we might discover that something is missing. And then we'll go back to the business people and the product people and say, hey, there is like the gap here that we didn't think about, and now we need to go back to the drawing board and make sure that we align with it. In our system that we just did, after the specs are reviewed and we still miss something, we won't know that we miss it all the way to the end of this process, right? Yeah, so that's a real problem. And the answer is, even after, no, well, sometime someone will discover it eventually. and when they discover it eventually, this is where we throw away this version, we go back to the prompt, we add the missing part, and we generate a new version that covers it. What you do now while writing code and discovering that something is missing will be discovered either because whatever we build just don't do what we need to do, or whatever we build just partially does and there are glaring functionality that is missing, and we're like, okay, we didn't think about it. You go back to the prompt. You add it to the prompt, to the software definition document. It's been added to the spec. And now you know that, okay, of course we missed it because we missed this part of the spec. Now it's there, and we go and generate it. It's exactly the same thing. We don't now look at the code as we don't look at the bytecode, or we don't look at the generated assembly. We look eventually from after the spec. If we missed it in the spec, next time we will be able to observe it and as on the QA stage after the code is already passed and we have something to look at. Yes?
I would say let's park it here. I'm going to be the main one because we're on a tight schedule tonight. Baruch will still be around during the break.
Yes.
Where Seth picks up for your room. So let's have a 15 minutes break for some drinks and beverages, which are waiting for you outside. And back at 1947, please.
Yes, and there are tags here that can, yeah. T-shirts, come to me for T-shirts.